Alright everyone, welcome back. This is part 2 of True FPS with View Stabilization. Before we begin, just a quick announcement. This morning we hit 100 subscribers on the channel. So that's very exciting. Thank you very much. In the last video, we tried to keep our head stabilized in space by just keeping its position and changing it only if it moved a certain distance away from its previous position. And that landed us in this mess where it works, but it just looks terrible. So today we're going to fix a couple of things. The first fix is an easy one. Instead of stabilizing the head, we're going to have the head moving regularly and stabilize an imaginary point that's relative to the head of where the point of view should be. To do that, we can go into our skeletal mesh, so Control P SKM Mani. And this is our skeletal mesh with the skeleton and all of its bones. And if we look for the head bone, it's the one that we've been stabilizing, we can right-click it and say Add Virtual Bone. A virtual bone is a bone that follows another bone regardless of what its parent is. So to the head, we're going to add a virtual bone that tracks the head. And you can see that it creates one with a pretty silly name. So instead of head, we're going to call it POV root. And this is the one that we're going to use. I'm not sure that this is the best way to do this. There are other uses for virtual bones, but that's what I got. Back in our stabilized POV, we can sort of refresh the animation so it keeps going. We're going to do the exact same thing, but in the end, instead of setting the transform of the head bone, we're going to set the transform of the POV root bone. If you try to find the POV root bone and it doesn't find it, then you might have to refresh the rig hierarchy. So just go to rig hierarchy here on the side and tell it to refresh to SKM Mani Mesh, and it should solve it. And already we can see that the head is back to moving as usual, so it's not stabilized anymore, but the green point, which is our head target, that is stationary. However, that still doesn't solve anything. We need to also change it here. So our follow camera in our BP third-person character, our follow camera, instead of being parented to the head, needs to be parented to the POV root. And now for the second, slightly more sophisticated fix. To do that, first I want to show you guys something. So let's remove the preview animation and take all of our hard work, and we're just going to set it aside for a second. Let's take a look at what the animation actually does to our character. For that, I want to draw a line just like we did before, and I want to draw it from the root bone. So from the root bone, I want to draw a line that goes straight up. So we're going to do it from the root bone to, let's say, 200 above it. Right? Here it is. This is where our root bone is. Now, if we go for, let's say, the run animation, you can see how far forward the head is ahead of where the root bone is. And I think it would be a lot smoother, a lot more stable, if you will, if the head stayed more or less where the root bone is and the body would follow behind it. So that's what we're going to do today. We're going to use inverse kinematics to get this to work. Let's add back some of our debug prints. I still want to know where the head is, so plug that back in. And also where the POV is. So we're just gonna duplicate this, and we're gonna look for the POV root. And again, let's make this a nice green. And just to keep things tidy, let's collapse this to function and call it draw debugs. Now we're going to use a full body IK node. The full body IK node takes an array of effectors, and each effector is a target for a specific bone in the skeleton, and the full body IK node uses these effectors, these targets, to solve the position of the character. Since we want to change where the head is, we're going to create a head effector, which is also a transform. And the value we want the head effector to have, the target where we're going to try and place the head, is more or less at the head height, but at the root bones X and Y axes. So let's do just that. Let's get the transform for the root bone. And if we open this up and this up, we're going to tell the head effector to be at the root X and Y. And the rest can come from the head bone, which is the rotation and the scale. Now for the Z-axis, which is the height, I don't want it to just be at the height. I want it to be a bit above, so it'll try to like stretch the head a bit. So we're gonna just multiply the Z value by 1.1, I guess, something like that. Before we actually hook anything up, I want us to add to the draw debugs the head effector so that we can see it. So it's gonna be right here. We can even make it blue. It's putting it at the ground right now because we're calling this before setting the head transform, the head effector. So we can put this after setting the head effector. Okay, and there it is. This is the blue dot is the blue point is the head effector. This is where the head is going to try and be all the time. Let's go back to the idle animation just for this demonstration, which is going to be, I think, funny. What we're going to do is we're going to create our chains. So we want the root to be at the pelvis, and we want the head effector to have the max effect on all of these properties, and we want it to go right here. Right now it's not doing anything because we haven't told it what bone it should affect. We told the full body IK node that you should try and put a bone at where the head effector is. We haven't told it what bone to put. So focus on the character when I tell it to try and solve for the head bone. So that's not exactly what we want. I mean, the head is where we told the head to be, but everything else moved along with it. We are currently hovering. Not only are we hovering, see how the feet are swaying, right? The feet aren't stationary. The head is stationary where the head effector is, but the feet are just floating, hovering, and swimming. That's because we didn't tell the full body IK node what to do with the feet. We just told it to put the head where we want the head to be, and it did just what we asked it to do. So for this, we're going to need a couple more effectors, specifically one for each foot. So let's create a foot effector left and foot effector right, and I'm going to get transform for foot left, and we're going to set it as the foot effector left, and we're going to do the same for foot right. Okay, so now we have effectors for the feet as well, and we can tell the full body IK node to add some more effectors and to place the feet where we want the feet to be. Setting the feet this way basically tells the full body IK node to put the feet where the animation wants the feet to be. So while I'm changing these values, you can see that things are changing in the preview on the side. Okay, and foot right. So now our feet are planted. You can see that they're not swimming anymore. They're planted, and you can see that the head is right under the head effector. This is the solution of the IK based on what we defined. We said we want the feet to be where we think the feet should be, and we want the head to be aligned with the root bone. We can even see what happens if we revert the head effector to look at none. So this is the original animation. This is just the idle animation. But now if we tell it to target the head, he sort of straightens up. And something very similar is going to happen if we change into the walk animation. Right? He's a bit more upright. Right? If I do this again, this is the original walk animation, but when we tell him to solve for the IK with the head, he's standing a bit more upright. Same thing with the running forward. So let's go back into the idle animation. And just to tidy up, we're going to separate this. This is going to be, let's call it the set effectors function. And after setting the effectors, we want to solve IK. And eventually draw the debugs. All right, and even one last thing, if we go into the draw debugs, we can add a print. I want us to print the POV roots location. And this is where it is. You can see that it's not perfectly stationary. It's moving around because the head is slightly moving around. If we go into the run animation, it's going to even be more pronounced. See, the variance in the numbers is greater this way. So now's the time to combine this with our earlier solution. So after solving the IK, which is what places the head bone where we want the head bone to be, now we can play around with our head target, which actually, it's not our head target anymore. This is our POV target, or evolving. We can see that we're doing two things with our POV target. We are initializing it, and then eventually we are setting it. So let's create a new function. We can call it initialize POV. And in here, we're going to put this code. Right here. So if the distance between the head and the POV target is greater than 12.5, then you can set it to the head transform and eventually return. I even think that we don't have to do this anymore. I think that if we ask whether the POV target is empty or not, and if it's empty, then set it to the head transform, I think that's good enough, given the new IK setup. I think that should be fine. So after solving the IK, we want to initialize the POV, and then we want to set the POV, which is basically this last bit. But since we took this away, I want to do something that's a bit different. So let's create a new function for calculate POV. And what we're going to do is going to be very similar. We're going to set the transform of the POV root. So it's going to be very similar. However, we're not going to just set it to what the POV target is. We are going to use the clamp spatially node, which does as its name suggests. It clamps a value in space. And we're going to use a sphere clamping. In a second, we're going to hook it up and you'll see the debug and you'll see what I mean. So what we're going to do is we are going to get the POV target value and we are going to clamp it in space to the head bone transform. We're going to update it with the result. And eventually, we are going to use its value to set the POV root transform. And if we plug it in now, nothing happens because we're not calling this function anywhere, right? Let's just leave this a bit nicer and tidier. And if we go back here and call calculate POV, now we can see this very weird big sphere. It makes sense that there's a very big weird sphere because we have a very large radius. Radius is 100. So let's knock that back down to like, 3. And so the debug can be a bit thinner. And we can already see, if we look closely, that the green dot, which is the POV, is hovering inside this red sphere. Let's get it back to the idle animation. It's going to be a bit easier to see. There you go. We have our red head bone floating inside this red spatially clamping sphere, and inside it we have the green dot, which is the POV bone, which is moving separately from the head bone. And in the debug print, you can see that it is perfectly stationary. Now, if we walk, then it is moving just a bit, and if we run, then it's moving a bit more. That's because the sphere radius value of 3 isn't going to work with all the speeds your character moves in. Right? The faster you move, the more head movement you have, so the larger value you need here. So now we're going to do something nice. We don't want this to be a fixed value of 3, so we're going to promote it to a variable. And we're going to call it max POV clamp. It's going to be a float, and we're going to hit this little I button here. So now when we go into our animation blueprint and we have our control rig here, we can see that max POV clamp is available to us. We can ask to use a pin to expose it. So the default value is still 3, but now we can modify it from the animation blueprint. And we're going to do that using a curve. So let's go next to the animation blueprint, and we want a curve. I want to create a new curve. It's this one. And we want it to be a float curve. And let's call it a POV velocity clamp. And let's take a look inside. This is what a curve looks like. It's just axes. And we want to add a new key. So the X value will be the velocity that we plug in, and the Y value will be the amount we want to clamp by. It's going to be the sphere radius. So when the velocity is 0, when we're standing still, we know that we want it to be 3. Okay, so that's 1. And now when we add another key, I know that the default max velocity for the Unreal default character is 600. So when we are at 600, let's give it, 10. We'll be able to play around with that. And this is just a bit of a sharp line, so let's hit this one for the automatic tangents, and just sort of smooths it out. It's a bit nicer. And back to the animation blueprint, let's add a variable, call it POV curve, and the type is curve float. This one's an object reference for curve float. If we compile, we can give it a value. So we're going to use the POV velocity clamp. And if we call the POV curve, we can get float value. And the float value, you can see that it asks for in time. It's just the x-axis. That's what it means. And luckily for us, we have ground speed already ready for us in the blueprint. So we're going to get it, we're going to plug it in, and we're going to plug this in to the max POV clamp. Now, we can't see anything right now. Nothing is happening. So let's go into the third person character. In the viewport, we can see that I have an extra camera set up for a third person view that's going to let us see what we did better. And let's hit play. Here we are in third person view, and we can't really see anything. So let's hit the tilde key and say a.anim.node.control debug and set it to 1. And now we can see our debug prints, and we can see our sphere and our POV root virtual bone in green. And this is the size that the sphere is when we're stationary. But if I move, you can see that it's bigger. And when I stop, it's smaller again. So that's cool. Let's go back into the character and deactivate this camera so that we can actually see what we did. Compile again. And when we play, we are back in true first person. Take a look at the top left corner. We can see the location of the POV root bone, and we can see that it is perfectly still. Now, if I move, it shifts a bit, but it stays almost exactly the same. And when I stop, then it sort of snaps back, not to where it was before. The z-axis was 160 before, now it's 157. But from an experience perspective, I didn't notice any snapping or any bobbing or any weird movement. That's because the Unreal units, if I remember correctly, are centimeters. So if we were at 160 before, and now we're at 157, so it would be 3 centimeters, which is basically nothing. It's a very small difference. See, 157.7, and I can jump up and jump down, and when I stop back again, I'm at 157.66. Now I'm going to move, and I'm going to jump again, and it's going to be 157.66. So it's the difference is negligible. On the other hand, some issues with this solution is if we look straight up or straight down, we still have a lot of clipping, even when moving around, especially around landing. If I take a big jump and land, and there was a bit of clipping. If we look up or down while jumping, then it looks very bad. So yeah, I'm gonna look at this and call it just not quite there yet. And I think that's where I'm gonna call it, you guys. I went on this tangent, this true FPS adventure, to try and get a solution that's easier for me to manage than syncing animations between meshes, and I'm not sure that's what I found. This has been very interesting. It's been very instructive, I think. I learned a lot doing this. I had a good time doing this, but I'm not sure it's a viable solution for me, for my game. I tried to follow the philosophy of what a game called Star Citizen did. It's a true first-person shooter. And, you know, they say how they had a team come up with a solution for this. So imagine little old indie me not living up to the same standards as a team of experienced professionals. Imagine that. But, you know, sometimes it is what it is. So thank you for going down this road with me. If you like what you saw, then feel free to like, subscribe, share. There's even a Discord. I try to upload a new video every other week. Most of it is for the game I'm making about a photographer joining an expedition to the end of the world. There's even a playlist and everything, so if that sounds cool to you, go check it out. There's even a pre-alpha out on itch. Links are in the description. Also, before I wrap up this video, I again want to thank you guys so much for the 100 subscribers. The fact that 100 people chose to be notified whenever I say something is not something I take lightly or for granted, so thank you very much. So I hope you guys had a good time. Stay tuned for more good things, and I'll see you next time.